Good afternoon and welcome to Design Master Training. My name is David Robison. Today we are going to be looking at the new features in Design Master Electrical RT 2.0. If you're attending the training live, you can ask questions in the chat box. If you are watching the recording of the training, you can call or email your questions. Our phone number is 866-516-9497 and our email address is support@designmaster.biz. So we released a new version of our software this week, and I just wanted to review the new features, show you what we have in the new software, give you a chance to check those out and ask any questions about those, and also any other questions you have about the rest of the software. We can entertain those as well. So in Electrical RT 2.0, the big feature that we added is one-line diagrams in Revit. Previously, we had the one-line diagrams in AutoCAD. And while those worked, a lot of people would prefer them in Revit. So we added them at Revit to just get everything in Revit, no more need for anything in AutoCAD. We added an entire new DM one-line ribbon. So this has all of the commands for creating the one-line diagrams. There's a lot of new stuff we have to have available in order to get the drafting right. Up here in equipment, we have the create and the link commands. Those allow you to put items on your one-line diagram. And there's two workflows you can have for this. In this case, I've got a project. If I pull up the panel edit command, you can see that I've got a number of pieces of equipment already created. If you're in this situation where you've already started a project and you want to build the one line based upon the model that you already have, the link commands are what you want to use. So we can use the insert link command. Run that, we can select the utility. I'm going to make a utility transformer here. And we can place this transformer on our one-line diagram. Now this graphic here in this drafting view is linked to the device in the model. So this is a drafting view, this is a Revit drafting family. If I run the highlight device command and select this, it'll go show us this is the actual utility in the model that corresponds to that utility on the one-line diagram. So changes to the model are going to be reflected in the one-line diagram. Generally, you're working, if you need to make changes, you make the changes to the model and then they kind of propagate down to the one-line diagram. So for example, if I run the Design Master panel edit command, select that utility, it's 75 kVA. If I actually change that value, and I'm going to put in 150 kVA transformer, if we go to the one-line diagram, it'll update. So we've got a nice link between what's happening in your model and what's happening on your one-line diagram. I can run the insert link command again, select this MDP. I'll put in a switchboard graphic for it. Put the MDP on the one-line diagram. It puts in that graphic for us, draws in the feeder as well. Out of the box, we have some graphics, obviously, so that you can do some work. These are what we put together as a kind of a representative idea of how people generally like their one-line diagrams to look like. We realize everyone does them differently. So you can customize these. They're just standard Revit families. You can modify them to look however you want. So if you want a different look and feel to your one-line diagrams, it's just a matter of modifying the graphics to how you want them to look. Our graphics do have a number of features included to make them a little easier to work with. You can reuse ours or create your own. So we can actually expand this guy here and make it bigger. Put the label back where it belongs. And we can continue using the insert link to build out our project here. We also have the ability to do the copy link. That's where if you actually change some of these graphics and you wanted to have them reused. So for example, say we don't want this label here, but we want it on the other side. I'll just pull it over here. And now I want to put a couple other panels with that label over there. I can run the copy link, select this panel. I'll put in panel P, locate it there, and it'll copy all of those settings, including where I placed that label. So the copy allows you to copy those graphics and then link it to something else in the project. You don't have to create your devices in the project ahead of time and then insert them in the one-line diagram. That's actually 100% backwards for how you probably actually do your design. You probably start with a one-line diagram, and you're like, transformer, panel, transformer, so on and so forth. And maybe you have a background from the architect. Maybe you don't. You probably don't have an electrical room. If you do, it's certainly not big enough yet. So you're not too concerned with where things are going to go. You're just kind of trying to build out your one-line model. Our software actually supports that workflow now with these create commands. So if I run the insert create, I can create a brand new panel called this panel P2. We can choose what level it's going to go on, just so it puts it somewhere. If you don't have a spot, you can use the default DM level. It basically throws it way up in space, so it's above everything, and then you can put it where it belongs. It's a little easier if it's on the right level to get it eventually in the right spot later. So we'll put it on the first floor. This is going to be a 480 volt panel. I'll choose an appropriate model. So we have to choose the graphic we're using for the one-line diagram and then what we're actually going to use in the Revit model as well. So you have two choices there. Click OK. It has to find a spot to put it on. And I'll connect it to this MDP here. So I'll put this P2 panel in. If I run the highlight device, and we zoom out to see where it is, here's my building, and here's my device. Basically, it looked for an empty spot. It found one way off in space and said, okay, I'll just start kind of building out panels here. And then later on, you can say, okay, this device, I actually want to place it in this room here. Maybe I obviously wouldn't put it there. I don't have a good spot for it. I've got my electrical room. It'll kind of fit here. So I can come down here and I can throw it in my electrical room. So you come back and you locate it later after you've built out your one line, but you can do your one line without putting anything in their physical location. So we could actually keep going here and say I'm going to copy that. I'm going to make another panel exactly the same. Also connect it. And again, we run the highlight, and it's again out here in space as well. So you can just keep building things, and I'll show you if you keep building them, it ends up kind of creating a grid of the devices, so they're just being laid out for you to locate later. And the idea being that that's a little bit more of a natural workflow, actually, in terms of how you do things. You're building your one line, and then you're going to go back and figure out the whole model later. We've got a bunch more features available for one-line diagrams. So this is all about creating your equipment. These next set of buttons are all about creating these feeders. Right now, this is a fairly simple one line, so we haven't had to do a whole lot. But for example, this feeder here got a little messy. There are a couple options. If I just run the feeder draw, I can redraw this feeder however I want. So if you have a place where you need to have it, I want to have it come in from the side, for example, I can do that. And you can draw that feeder however you like. These feeders are made up of actual families rather than Revit line work, so that they mask each other, so that if you draw your feeders over each other, they'll hide the other feeders behind them. So if I take this feeder, I don't recommend you actually draft your one lines like this, but you can if you want to. Software allows it. And you'll see that the feeders where they're crossing, because of the mask, they're going to put in the crosses automatically, which is a nice little drafting feature that Revit gives you. Now we can pull this ID up. There's a bunch of other commands for doing feeders and for adjusting your graphics. We don't need to go over all of those right now, but that's just to give you a flavor of how the one-line diagram works. We've completed the tutorial at this point, so if you go to the website and you go to the tutorials, it walks you through all of the features and can show you how the one-line diagrams work. The next thing we'll take a look at is breaker curves. So we've added the ability to assign a specific breaker to the breakers in your project, which then assigns the curve that's associated with that breaker, which we can use for selective coordination purposes and arc flash trip times. So if I go to this MDP panel here, it's a 100 amp panel. It actually is connected to the utility. So we're going to jump down to the panels that it's feeding. So we'll go to this E panel here. Also a 100 amp panel. It has a 100 amp circuit in the upstream panel. So we can set that curve for that breaker, running the select breaker curve command there. And we've got a list of breakers here that we can choose from. We're slowly expanding this list, so if the breaker that you're using in your specific project doesn't exist yet, we've got a link there. You can email us directly, say, hey, I need this specific breaker, and we'll get it added for you. The list of breakers is long, but it's also finite, so we're slowly building out to have all the breakers that you might need. We have a pretty extensive list of Eaton. A lot of people said they had standardized on that. So if you're using Eaton breakers, you generally can find what you need. And we're continuing to add more based upon what people request. So you can choose your breaker type. If it's an electronic breaker, you can then set all of your electronic settings. I'll leave these as a default. And I'll also do something for panel P2 here. And this is going to be a thermal magnetic, so it'll have a slightly different looking curve. So that allows you to set your curves. You can then actually insert them in a drafting view to see them for selective coordination purposes. So we've got the new commands here to insert a selective coordination graph. I'm going to add a curve for panel E, and then I'll also add panel P2, which we created. Click OK, choose a spot on the drafting view, and it'll draw in the curves for you. So there are the two curves for those two panels. It also locates the fault. If I run the calculate, it'll update everything because the fault at P2 obviously is way high because it haven't had the calculation run yet. So if we run that, it'll update, and then we'll get a slightly more realistic looking graph. There we go. Now fault 2, fault at P2 is more realistic. So if you have multiple breakers, you can put them all on this graph and make sure they're not overlapping for your coordination purposes. You can also modify them directly from this graph. So if we run the curve edit, we can select this thermal curve. And actually, it doesn't have very many options, so it's just what it is. We can run the curve edit and select this electronic curve, and we can adjust the settings for that one as well. I'm going to change this short time delay. It's actually not even showing up a little bit because of all the other settings. So there we go. We adjusted the short time pickup, and that pulled the curve up. These curves are also used for the trip time for arc flash calculations. So at the bottom of your panel edit, we have all the arc flash calculation settings. So to do arc flash, you need a little bit of additional information about the actual configuration, like how it's physically put together. You put all that information down here. It eventually calculates an arcing current. And then from the arcing current, you use these curves to calculate the arcing time. And so we will, if you've assigned a curve, we will give you the arcing time. If you haven't assigned a curve, we use a default value of 2, which is kind of the maximum that you ever assume that someone's going to stand in the arcing current. The assumption is they jump out of the way or are blasted out of the way after 2 seconds. And then based upon that arcing time, you can get the incident energy and the arc flash boundary values. So the arc flash calculations, those aren't necessarily new. That's been in the software for a little while. What is new is that we can give you these arc times automatically based upon your breaker curves. Those are the two kind of flagship features for this release. We also have a number of refinements to the calculations just to make it a little bit easier to document what you're doing and to get it to calculate the wire sizes automatically how you want rather than having to manually choose it in situations where you're kind of going off of what the software by default is giving you. First, on all of your branch circuit pieces of equipment, we now have the fault as a shared parameter. So if you need the fault at a branch circuit device rather than a piece of electrical equipment, it's now included as a shared parameter. So you can see those values. Previously, it was limited to like panels and transformers. To get the fault at a motor, you had to do a little bit of work with the modeling to get it to work out. Now every device can display what that fault is. So that's included both in the shared parameters on the device itself. And then if we select the circuit, it is also included as shared parameters on the circuit fault values. For transformers, we now have the ability to specify the overcurrent protection size for the specific size of the transformer. That's under customization, transformer overcurrent protection sizes. Here, for a specific voltage, And for a specific size transformer in KVA, you can specify what the overcurrent protection size should be. We originally had this as a calculation, and we were getting some feedback that the calculation wasn't matching the standards that people had. And so we tried to adjust the calculation, and what we discovered is that everyone has a slightly different interpretation of how they like to size their transformer breakers. And so we weren't able to come up with a calculation that matched everybody. So now you just tell us, for this size transformer, this is the size breaker I want to use. We have new options for sizing wires. Down here in the feeder sizing, we've got some additional options. So you have your sizing option that's being used. So there's a default for the project. So by default, we're sizing everything to copper wire. We can also choose a specific sizing group, saying instead of using copper wire, I want to use aluminum wire. If you select that, it's going to use aluminum wire instead. Previously, if you wanted to use aluminum wire, you had to specifically choose the aluminum wire size. Then if your panel size changed, you'd have to remember to change your conductor sizes. And it was just a little bit of extra work and opportunity for mistakes. Now you just say, okay, I'm using aluminum, but I still want you to size it automatically. And then in cases where you do need to choose a specific size, you still can do that and give us a specific size for the wire. We also added the custom wire size, where you can select custom, and then you can type in any sort of description that you want and give us any X and R values for your impedances that you want. One place where this is used is if you have a bus duct. You can say, okay, this isn't actually a wire, this is a bus duct. And then you go to the manufacturer and you look up the bus duct impedances, which are usually much smaller, and you type those in. And then you have a bus duct modeled rather than a piece of equipment, or rather than wires. You also could use it for a one-off existing circuit where you've got one circuit that's a specific size in an existing building and you don't want to go adjust your customization for it. You can just type in what it is, put in the impedances. This also allows you to do multiple parallel runs of conductors in a single conduit. The software doesn't have an option for that by default. If you're doing parallel runs, we assume you want separate conduits for them. But if you want to put them all in one conduit, you can come in here, give us the custom callout as you want to describe it, and then give us the corresponding impedance values. So we could come in here and do custom. So say we want to have 2 runs of however you want to do that, 2 runs. So you can just, whatever description you want to put in there, you can. And then obviously you'd upsize or adjust the impedance values. And then reset that back to the default. For the wire sizing, we've also added the wire ampacity separate from the breaker ampacity. So all of the wire sizing happens here in terms of choosing what size wire to use for what size circuit. Previously, we had just the breaker ampacity being listed. So the software, you'd get a breaker size, and then we would size the wires based upon that. And that's still how it works. So for a 40 amp breaker, you're going to get either a number 8 copper wire or a number 6 aluminum, depending on which sizing method you're using. However, we are also now recording the wire ampacity, which in this case is 40 degrees, and then the temperature rating of the conductor for this whole configuration, 60 degrees. If we come down to the 50 amp line, you can see that the wire ampacity is 55 degrees. So the wire actually is rated for something higher than the breaker. We can use this when we then derate the wire for multiple runs of wire in a conduit and for the ambient temperature. We have the ability now, when you're doing a neutral, when you say that the neutral is a double neutral, we'll assume that you're doing that because it's going to be a current carrying conductor, and we will actually derate the wire based upon that wire ampacity and give you slightly larger wires. So it went from number 1 to 1/0 wire for the double neutral. We also will derate for ambient temperature. So by default, everything's at 30 degrees. If this is actually a warmer space, we can set it to 35 degrees. And then it will derate the wire as appropriate. It doesn't always necessarily need to go up. So there it goes. It upsized it to 2/0 wire. So previously, To do all of this, you would have to manually set the wire size, which worked. But again, if something changed, you had to remember to also change the wire size to account for it. So now it's sizing automatically based upon these settings, which is more convenient for you. It's also much better documentation so that when someone else picks up the project, they're not wondering why you've locked this wire size. They know that, oh, you're sizing this based upon a double neutral, or you're sizing it based on a higher ambient temperature. So your design intent is actually more clear with these additional options as well, which is helpful for other engineers or you when you come back to a project after it's been put on hold for 6 months and can't remember what you were doing. We added a couple additional new buttons to the panel edit. One is the ability to calculate part of the project. Previously, you could calculate everything, which takes a little while. If you run calculate part of project, it'll calculate from the selected panel and then everything downstream of it. So if I run calculate part here, it's just going to do this panel and then the panel right below it. It's a little faster if you want to update your calculations for just a small portion. Then we also added this new highlight panel command where you can select the panel and then select the highlight panel, press the highlight panel button, and it will show it to you. And in this case, since it's actually in the model and on the one-line diagram, we could show it you in either place. So I can say, yeah, highlight it in the model. There it is on the model, so you don't have to wonder where it is. In the same way, we can take that P panel and say, okay, where is it on the one line? So we run the highlight panel, highlight on one-line diagram, and there it is. So it makes finding your stuff a little bit easier, and as you get bigger projects, it's really easy to lose track of where that actual thing is. Again, if you've left a project, if you're working on someone else's project, or if it's just a particularly large project. That's available on the panel edit. It is also available on the DM1 line. I was using this earlier. You can use highlight device. You select the device, and it'll show you where it is. That actually works in the model as well. If I press highlight device here, it'll go show you where it is on the one line. So that'll basically take you back and forth between the two areas. We also have on circuit edit, highlight panel is available there. We also have the highlight circuit. So this will show you where devices on a specific circuit are located. So this has this cooling load. If I do highlight circuit, I'll say, okay, that's where it is. It's apparently up here on the roof. This isn't maybe the best view, but at least you have some idea where it is, and then you can locate it. If there are multiple devices on the circuit, it'll show you all of them. So, okay, if I take this lighting circuit, do highlight circuit, here's all of the light fixtures that are on that circuit. So it's just a little bit of a convenient way for tracking down where stuff is in your project. The last thing I want to highlight for you is that at the beginning of both of these ribbons, we have a pull down, which lists all of the same commands. And from the ribbon itself, it's not very helpful because all of these commands are also available here. So there's no reason you'd use this pull down necessarily. But you can right click on it and do add to quick access toolbar. The one line diagram has the same thing, all of the commands, right click, add to quick access toolbar. I can then adjust Revit so it refreshes. Now we've got those both of those buttons up here at the top of Revit. We can click on them and you have all of your commands available as a pull down menu. Revit likes to flip around which ribbon it's showing you. I come in here and I select something, and then Revit decides to move off of the ribbon you were on and show you something else. Generally, it's being helpful, but if you're using our commands, it can be, taking out of the context of our software. So these are then always available, no matter what Revit is deciding to show as the active ribbon. So there's one, the E is the main electrical one, and then the one is the one-line diagram. I did want to talk a little bit about the customization for the one-line diagrams that we have, and specifically how our customization is intended to be used. So we are giving you a set of families. Families in Revit have a lot of complexity available to you in them. So we had to make some choices about how our families were going to work, that were going to work for as many people with as few modifications as possible. And you can look at these families and you can think, I might have done that differently. And I would agree that there's lots of different ways you could have done this. And for your specific workflow, how you like to use Revit, they might not be the best choices. But we at least want to explain the thinking behind how you're intended to use our families, and then you can use them as they are or modify them to match how you like to do your drafting. When you put in a device, you choose the family here. And we have two types for all of our panel families. We have solid and dashed. And that controls the line work of the outside portion of that device. So if I click that panel there, you can see we've got the solid and dashed as types here. So I can change that to dashed, and that'll give you a dashed line. It's pretty common that people use a dashed line for various purposes. So just to make that simple, we built it into our families so you can toggle between those two. In the same way, we have a checkbox for whether the line work is new or existing. So it's a checkbox to turn it to existing. So if I check that, it'll turn it to existing, which is a slightly thinner line weight. If I toggle it, you can see that it gets a little bit thicker. The line work that we're using under Manage is in the object styles. If we go here to detail items, all of these DME styles are the ones that are being used for our one-line diagram. And so if you want to use different line weights, you can adjust these in your template, and then when our stuff is pulled in, it'll see that you've got these defined and it'll use your settings. So by default, our light or existing line work is line weight 3. Our heavy line work is line weight 5. There's nothing at all standard about what a 3 or a 5 line weight means. That's entirely up to how you have things set up in Revit. So we chose 3 and 5. They seemed like decent options, but there's no way we're going to match what you're doing, because if I talked to 10 different companies, I would get at least 10 and maybe 12 or 13 different ways they like to set up their line weights. So you need to make sure that the line weights that are being used match what you want them to look like. You can also adjust the color and then the pattern. We have a DME dash that we're using for our dashed line work. You could adjust it to something else that you like to use. But if we want to, we could change this from a 5 to a 6, and we'll get slightly thicker line work. So that's just a matter of choosing the line styles to make them look right for how you like your drawings to look. These panels here, these panel boxes, have a lot of these little grips. In AutoCAD, you would call them grips. I don't actually know what they're called in Revit, but you've got these little grips where you can move the things around. We've built those in. Again, that's standard Revit functionality. We worked hard to make sure that these ones would work pretty well for what people wanted. So you can actually adjust the size of this box. You can move where this bus is going to live. You can adjust where this part of the bus goes as well. In your shared parameters under graphics, where we had the existing, we also have other toggles depending on the specific thing you have in there to adjust what things are looking like. So this is where you would always go to look to see if there's anything else you need to adjust. In this case, I can turn that top lugs on and off. So if I turn that off, it goes away. And that's just a question of what you want to do for your graphics. If I edit this panel, right now it has main lugs only. If we change it to a breaker or a fused switch, the graphics will also update to match. So we'll put that in, and we will put that label in. So that label is fixed. You can't actually move that label independent of the panel, but it'll show there with the breaker size. So that label is one that's actually embedded into the family, as opposed to this label, which is a standard label, can be moved around a little more easily. I'm going to put in another panel because we have a couple other options here. We've got the panels, which are kind of those boxes that you've been seeing. You've got the switchboard, which is the horizontal piece that you've been seeing. We also have the switchboard with the tab. And I'll just put one of those in to show you what that looks like. That has an extra tab here in the outline of the panel. And again, a bunch of grips so you can adjust how this actually ends up looking. So you can adjust this however you want it to look. And if our graphics don't work for how you like your graphics to look, you can create new families with the graphics that you like. For transformers, we have this utility transformer, which I put in. For transformers actually in the project, we have a couple options. I can put in this T1 transformer. We have the option with a box or without a box, and with a ground and without a ground. So if I do box with a ground, and then where it's going to be fed from, that'll control how the graphics connect to it by default. You can always draw the feeders however you want, but you need to tell it, okay, this transformer, I'm going to feed it from the top, or the bottom, or the left, or the right. So if I do fed from top, put in this transformer, it's going to feed it from the top, and it'll give us this box in the ground as part of the graphics. You can change the family that's being used by using the add modify graphic. If I run that, I can select this family and I can swap it in something else. So we're using the box with the ground. I can change it to do no box and no ground. And it gives us an option when you change the graphic to move the labels to where they belong with the new one, because we kind of have default label locations, or leave the labels where they are. I'll update my labels so that they look nicer. So that's what it looks like without the box, without the ground. So again, it's a question of what kind of style you like for your one lines. We have a couple options for transformers to kind of hit what you might like, but if these graphics don't exactly match it, you can go in and adjust them. We've been looking at the panel graphics and the transformer graphics. We also have other distribution equipment, and so we have a number of different graphics included for those as well. Transfer switches, a generator, some junction boxes, and some disconnects. So we have these other graphics available as well that you can use. And these are for things that are in Revit electrical equipment that maybe you don't want to have look like a panel specifically. Something like a transfer switch. Or if you just want to do a junction box for something, you can do it that way. And it's nothing special. Circle with a J in it. We also have branch circuit equipment. This is your motors, air handlers, things of that nature, where we can specify, we've got equipment connections, motor connections, junction boxes, and disconnects again, and then always you're choosing the family that you're actually going to put in the model. So if we want to put in this motor with a disconnect, and then we can do a motor connection, you'll get that motor graphic. These don't have solid dashed, they're all solid. They do still have the new existing toggle, so you can use that on these. For circuits, we have a number of graphics as well. We have breaker graphics, or overcurrent protection graphics really, breakers and fuses and such. We've got the IDs, and then we have other graphics that you want to put in. So this graphic here is specifically linked to the breaker for this device. So when we modify this device here, we actually, in the one-line diagram, are specifying what breaker type graphic to use for it. So its overcurrent protection is kind of using a default. It's basically saying I want to use whatever is the upstream device. I can specify what breaker. But I can say, okay, actually I want a fused switch here. I can change it here for this transformer, and then it'll update it on the one line automatically. So you can control your graphics through your panel edit if you want to have it set up ahead of time. You can also use the modify to select this and add a new graphic. And when you select it, it actually is going to ask you, are you changing the overcurrent protection graphic, or do you want to add something new? So we'll first change the overcurrent protection graphic. So it's right now it's a switch, it's a fused switch. Maybe we want to change it to a non-fused switch. And it'll change that graphic. If we want to add something else down here in the other half of this line, we can say, okay, I want to add an additional graphic, and here's where we can choose something else instead of these breakers and disconnects. Maybe we want a meter in there. So we can select the meter, choose the meter type that we want to use, and it will put that meter in for us. Again, the meters have some options for adjusting what they look like, adjusting where the meter is located, and then the toggle for new versus existing. If I check that, it's going to change just the graphics of this little meter and not the feeder line itself. So it's doing just the meter. The feeder lines we have set up to be controlled by the type. So if I select this, you can see that we've got medium solid dashed, light solid, light dashed. That's for the line work of the feeder portion itself. So if I go light dashed, you'll see that now the line work is light dashed. This feeder is actually made up of multiple different pieces, so it's only going to change the one. So we have the command to adjust that, the feeder phase command, which is, we're kind of using the Revit wording of phase there because it's really changing like new and existing, but what it actually ends up changing is the type. So we called it feeder phase because that's really, you're changing the phase, new, existing, but it's in reality going to be changing that type. So if I select feeder phase, select this feeder, and then choose a setting light solid, it'll make all of the pieces on that to be light solid. So then now they're all matching with that light solid. It's not as obvious. If I go feeder phase and do a medium dashed, it'll be more obvious that everything's changing. So it's a little bit heavier, and now they're dashed line work. So that's all being controlled by the type. So if your types of your feeders all are using the same names, our software can go through and adjust them all for you. And in cases like this, that is helpful. The IDs, you can move them back and forth and where they actually live. They also have an ID width, which again is controlled in the graphics shared parameter. This controls how big this box is. Right now it's set to 1 inch. If I set it to 1/2 inch, we'll get something smaller. So you can adjust what that looks like there. And then we have by default a hexagon, and we have other options as well. I can come in here and change that. I'm going to replace the ID graphic from a hexagon. We'll make that into an oval. If we have an oval and then a rectangle. And that will choose an oval ID for us. Under your options are where some of these choices are set. So if we go to project options, and I'm going to expand that. Down in the one-line diagram, it controls what defaults are going to be used for a lot of those feeder segments. So we've got the default, just the segment that's being used for the feeder at all, and then the breaker, panel breakers, and transformer overcurrent protection, what values we're using there. The feeder IDs are actually controlled in the project feeder ID schedule under the group, because you can actually have different groups of feeder IDs if you want to. And then each group has a different ID that's being used. So we can come here and set, instead of I'm using a hexagon by default, I want to use an oval for everything. And then the next time you calculate, it's going to see that that changed, and it'll pick that up, and it'll give you ovals everywhere. So that's how our customization works, kind of the thinking behind it. You obviously can adjust it to match whatever you want to do. You don't have to use our customization, but we wanted to include something with the software so that out of the box you could have some success drawing a one-line diagram. So if you want to use ours, that's kind of the philosophy that you want to use and how you want to approach adjusting the line weights and using of them. Thank you for watching today's Design Master training. Contact us with questions or comments by calling 866-516-9497 or emailing support@designmaster.biz.